Okay, so I'm going to do this in 3 segments for each type of problem. So we'll start out with the elevator problems first. I've gone over this with some of you guys in class, but let's put it here on paper and video. So we have an elevator that weighs 3 times 10 to the 3rd newtons. It's accelerating upward at 1 meter per second. What does the cable exert to give it this acceleration? So first of all, let's draw our free body diagram, as we always have to do in these situations. Here is our elevator. Going down is the weight force, which is equal to, they tell us, 3 times 10 to the 3rd newtons. And of course, going up, and it's accelerating up, is our applied force, or what would be on a scale if we had a scale on the elevator. So this applied force is actually what the question is looking for. It says, what force does the cable exert to give it the acceleration? So this is our givens and our drawing in one, and our acceleration is equal to 1.0 meters per second squared. So the tension, and this is the force of tension right here. Force of tension, remember we talked about that when we did our little station lab. The tension force in this cable is what they're looking for. So remember I said the equation that we always have to keep in mind in these cases is the one that says that the sum of the forces, which will equal the net force, is equal to the applied force, which is going up, and we'll call that positive, minus the weight force, which is going in the opposite direction. Okay? And in this equation, we also know that the applied force, or the net force, excuse me, the net force is equal to MA, because we know that force is equal to MA. So this net force here is M times A is equal to FA minus FW. Okay. This just means that if I'm looking for FA, that's what I'm looking for. My question is, what is FA? Then I just turn this equation around and say that FA is equal to MA plus FW. Okay, so I know that my acceleration is 1. That comes from here. I know that my FW is 3,000 newtons. That comes from here. What I don't know is what my mass is. However, I do have a way of finding that out, because I know that force is equal to the weight force, that is equal to m times the acceleration due to gravity. So if I want to get my mass, all I have to do is use my weight force, because this is equal to m times g. Use that weight force to find out what the mass is. So in doing that, I will find out that my mass is equal to the 3 times 10 to the negative 3rd, or excuse me, not negative, 3 times 10 to the 3rd divided by 9.8. So that is what I've got to put in for my mass. This, if we do this, rounds off to about 310. So now all I have to do is my addition here, and this is going to round off to, it's going to be like, I think, 3,000 310, but it rounds off to 3.3 times 10 to the third newtons. That's our answer. Okay. So now, what about in the second problem? In the second problem, we have exactly the opposite situation. In this problem, the elevator is actually slowing down instead of speeding upwards. So again, we draw our diagram. The most obvious vector is the weight force vector, and it tells us that a person weighing 490 newtons, so that means when the elevator is totally still and you were on a scale in there, it would be 490 newtons, which we know is also equal to mass times g. Okay, and we know that the other vector is the applied force vector, and in this case, it is equal to a negative 2.2. Oh, excuse me, it is not equal to a negative 2.2. It is equal to ma. It is equal to mass times acceleration, and we know that that acceleration right here is equal to negative 2.2 meters per second squared. That's what this piece of information right here tells us. Make sure our answers are all plain here. This is going to be our answer we're shooting for. So it wants to know, what is the scale going to read in the elevator as it is slowing down? Your intuitive sense should tell you it's going to weigh less than, it's going to show less than what the person initially really weighs if the elevator was still. So again, let's do our equation here. Our equation says that the sum of the forces is equal to the net force, which is equal to the applied force minus the weight force. Okay? And this time, what we're looking for is, again, if it's what the scale read, that means that we're looking for this applied force right here. This is the question. All right, so the first thing that we want to do is change this equation around so it shows what it is that we're actually looking for. That means that the applied force is equal to the net force plus the weight force. Okay? And we know that the weight force is 490 because that's what they told us right here. Okay? We know that the acceleration here, we know, we should have put in, I guess, that this is equal to mass times acceleration. So that means this is equal to mass times the acceleration of negative 2.2. That's what they told us here. Okay? Let's see. Okay? So again, we come down to what is the actual mass, and we have to derive it from this equation here, because we know then that 490 is equal to the mass times 9.8. So we need to take 490 and divide by 9.8, and that'll give us our mass, and I believe that comes out to 50. Let me check that. Yes, it does. It comes out to 50. So that means then that we need to substitute 50 in here. That means this is equal to 50 times negative 2.2 plus 490, and that all equals 380 newtons. Okay, so that's elevator problems. Look over that and see then if you can understand that. If there's any questions, let me know in class.